Now, due today is this green paper that most of you have already turned in. Most of you finished this green paper really fast and turned it in. But what I've noticed is things that you finish really fast because it's really easy is also, it's easy to forget. So, how do we do, and I asked you as you were working the problems to see if you could figure out what the shortcuts are. So, x squared times x to the third power, that would be the expanded form, but what's the shortcut? Just add those together, and that's x to the 5. You can expand it, or you can just add those together. That's a 5 and a 4. So what's 5 plus 4? If you have numbers out in front, you go ahead and multiply 8 times 2. What if it doesn't have a number? Then the number is 1, so this is a 9 and a 1. 5 times 6 is 30. This is a 9 and a 4. 9 plus a 4 is, and you keep the same base. Is the base is x, the base is x in the answer. Okay, what about raising a power to a power? Instead of expanding all that out, what can you do if you have a power raised to a power? What's the shortcut? Multiply 3 times 3. But do you see that the shortcut has to match the expanded answer? Okay, what is the shortcut here? 4 times 2 is 8. Did you find the shortcut for division? If I expand it out, I can cancel. Subtract. 7 subtract 2 is x to the 5th power. That's what's left. And do you see that the shortcut has to match our expanding? So 10 subtract 8 is 2. But what if the 3's on the top and the 5's on the bottom? X squared, it would be 1 over x squared if we expanded it. But what if we subtracted it? And that's why x to the negative 2 is equal to 1 over x squared, because our rules have to match our expanding. And that's where this rule came from that was on your notes, on those green set of notes. When you subtract and get a negative number, that's the same as that number in the denominator. And a negative exponent, this would be 3k times 2 with a k to the 4 in the denominator. That's what it means to have a negative exponent. It means that's in the denominator. So what is that reduced to? Well, let's go back and use our rule. 3 times 2 is 6, and we add, what if it doesn't have an exponent? The exponent's 1, and so to multiply, you add the exponent. What's 1 plus negative 4? But it is considered bad form to leave a negative exponent. Now hear me. I did not say a negative number. What did I say? Negative exponent. You can't leave a negative exponent in your answer. And so that's what you would have gotten if you'd expanded it all out and canceled it out. What's our rule here? If we have a power raised to a power, 4 times negative 3 is negative 12. A negative exponent is also called a reciprocal. It's equal to a negative 12 in the denominator. We're going to come up with some problems like that. And I forgot to put an example up here on the board just to remind you. Anything to the 0 power is equal to what? Okay, now turn to the back of your notes and let me refresh your memory about simplifying here. This is just a regular square root. 24 is not a perfect square number. If you have a number that's not a perfect square number, how do you simplify it? Do you remember birthday cake? Did I already tell you? Okay, never mind. So when you have a birthday cake, you always start dividing by 2 if 2 will go into it. Will 2 go into 24? 12. 2 will go into 12. 2 will go into 6. 2 won't go into that. And the reason you make a birthday cake is so that you can find groups of 2, because this is a square root. A square root asks what number got multiplied by itself. So what number got multiplied by itself? 2. And what is left over? 2 times 3 times 1 is 6. That's how you simplify a square root. But this next one is not a square root. This next one is what kind of root? This next one is called a cube root. This number right here is called an index. This index is telling me I'm not looking for groups of 2 this time. I'm looking for groups of 3. I'm looking for numbers that got multiplied by itself 3 times. And that's why I like teaching the birthday cake, because you already know how to do this. Because you start exactly the same way with the birthday cake. But if this number right here is 3, instead of making groups of 2, you're looking for groups of 3. That's the only difference between finding a square root and a cubed root. And so I have a group of 2, and what's left over? Now, that's not quite right. Because if the index is not 2, you have to write the index in there. That's a cubed root, not a square root, so I need to see a little 3 right there. If the index is not written, it's a square root. If you wanted to write in an index, it would be an index of 2. So what do you think it means if there's an index of 4 right there? Groups of 4. Do we have any groups of 4 over here? No, so that's not going to simplify anymore if it has a 4th root. Okay, now we're ready for the front of your notes. Now, the first part of your note starts out with a little chart that I skipped, helping you understand different kinds of roots and powers. But I did want to point out your vocabulary. This little number right there is called the index number. The index number tells you what you're trying to group. Groups of 2, groups of 3, groups of 4, groups of 5, 6, 7, whatever the little number is. As I told you before, this symbol itself, the symbol itself is called a radical sign. And the number under the radical sign is called a radicand. And then it gives you a little chart about -1. What is the square root of -1? I. What is the cubed root of -1? Is that I also? What's that equal to? Because -1 times -1 times -1 is still -1, and it gives you some other roots there. And then I'm going to also skip the next little chart, and we'll come back to it as we come to it in the problem. So let's go ahead and go to example number 1. Now, what kind of root is example number 1? It's just a regular square root. If there's no index written, you can put in an index of 2, but it's just a regular old square root. The reason we don't usually put in an index is because that's the most common root that we ever use. Now, it's a negative 36. So that would be and I'm going ahead and expanded that x to the 6th power. Now, what's this equal to? 36 is a perfect square number. What is the square root of 36? And then for our variable, expand it. How many I didn't make the right kind of groups, did I? What kind of root is this? A square root. So I need to make groups of 2. How many groups of 2 do I have? Well, I'm just messing this up all over the place. Okay. Now, that's not usually the form we write it in. We usually write the whole number first, and then the I, and then the variable. That's usually the format of the answer. Keep doing that. I just don't want that number right there to be, you think I'm prejudiced against 3 or something? Okay. Okay, do you all have the right answer written down? Because I certainly didn't. Okay, this one right here is just a regular square root. 40. Now this time 48's not perfect. So if 48's not perfect, what do I need to do? So I need to make a birthday cake, and 2 will go into that, and 2 will go into that. 2 will go into 12 6 times. Okay, so here we have that all expanded out, and I'm going to write my 1, 2, 3, 4. That's the x to the 4. Okay, here's the 2 that's out in front. Since this is a square root, I'm making groups of 2. So I have a group of 2 and another group of 2. Group of 2, another group of 2, and what's left over? And then I have x's. Do you see that my x's, did I have anything left over? So I'm not going to have any x's under there. How many groups did I have? This part right here is the 48. That's the x's. This is the 2 out in front. Okay, so what's 2 times 2 times 2? That is called the simplified answer, even though to you it doesn't look very simplified. Now, how does it change if the index is a 3? Still start with the birthday cake. This doesn't divide by 2. This divides by 3. 3 will go into 27 9 times. 3 will go into 9. So the only difference is, if you already know how to do the birthday cake, the only difference is I'm making groups of 3 instead of 2. And so 1, 2, 3, 4, 5. That's what x to the 5th means. And because that index is 3, I'm making groups of 3. Okay, so what do I have? I have a negative sign out in front. I have a group of 3. Do I have anything left over? On the number part. Okay, now what about the x's? I have one group of x's. What do I have left over? So that would be an x squared left over, and you have to have this 3 index as part of your answer. That is the simplified answer. So if you know how to do the birthday cake, it's real easy to change from square roots into cubed roots. That is not what I wanted to do. So this has a negative sign in it. That's -1 and the 24x to the 9th. So I'm going to make a birthday cake. 2 will go into 24, 2 will go into 12, 2 will go into 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And since the index is 3, I'm looking for groups of 3. I'm making groups of 3 because the index is 3. So I have 2's. What do I have left over? This is the 3 that's left over. What about my x's? 1, 2, 3 groups. Do I have any x's left over? But what about this? Look on your first page. What is the cubed root? Is that an I? It's just a -1. -1 times 2 would just be a negative. It's only if it's a square root or a 4th root that this is equal to I. It's not I because -1 times -1 times -1 equals -1. And so if it's a 3rd root, this is just equal to a negative sign out in front. Start with a birthday cake. 64. 2 will go into 64. 2 will go into 32. 2 will go into 16. That is a lot of 2's. After you have your birthday cake, what is it that you're looking for? The index is 3, so I'm looking for groups of 3. Groups of 3, groups of 3, groups of 3, groups of 3. So I have a group of 3. I have another group of 3. I have a group of 3, and I have another group of 3. Do I have anything left over that's not in a group of 3? Everything groups up. This would be a perfect cube. This would be 4a squared. And why isn't there any root in the answer? Why isn't there any radical sign in the answer? Everything made perfect groups except the one, and we don't count him. Okay. How do we start? Birthday cake. 2's not going to go into that. 3 will go into that. 3 will go into that. 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait. I was making groups of 3. Am I supposed to be making groups of 3? What is the index? 4. So what do I need to make groups of? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I have a 2 out in front. That's the 2 that's out in front. And then I have a group of 3, a group of X, and another group of X. Do I have anything left under the radical sign? No. And so this would be 6x squared for my final answer. Okay, you tried this one. Did you get the right answer? We had a group of 2's. We had a group of A's. We have a 5 left over, and we have a to the 3rd power left over. The assignment 8-7 is due tomorrow. I need you to practice this or you will not be ready for your lesson tomorrow. So this is due tomorrow.